If you buy an electric skateboard or build one, or even a drone or an RC car of any kind, they all have an ESC or an electronic speed controller that is the brain of the system. It takes the input from the controller and sends pulses to the motor. However, you don't have any control over the ESC, which is more like a black box. So the acceleration and braking is fixed. And it is too hard for my liking. It almost throws me off the board. So there's a need for more control, and thankfully, Benjamin Vedder developed an open source ESC called the VESC or the VESC. The VESC is customizable to a great degree. You can set your acceleration, your braking, you can control the current and set maximum values for a lot of things, and the list goes on and on. So I thought of buying one, but since I had the tools to do SMD soldering like a microscope and a hot air station, I thought why not build one? So let me take you through the process and you decide whether it was worth it or not. Now, since the VESC is open source, the hardware and software files are all available online. The first step is to get the hardware. So I downloaded the Gerber files for the PCB and sent it to my favorite high-quality PCB supplier, PCBWay. PCBWay is a professional PCB supplier where you can order your PCBs from only $5. Simply upload your Gerber files and you will receive a code for your PCBs. They're also currently running a promotion that you can avail for up to 25% off Flex PCBs and 30% off advanced PCBs. Now the VESC PCB is a complex 4-layer PCB, so it is a little pricey. I paid a total of $50 for a set of 10 PCBs, which is again only $5 per PCB. I also ordered some stencils, which cost me $15 each. Upon unboxing and inspection, the PCBs were absolutely flawless and ready to go. So I put on my stencil and spread the solder paste all over it and placed the components. There's a BOM or bill of materials for the components, and there's about 140 components to be ordered and soldered on. You can simply order them from Mouser or DigiKey, but some components are not available all the time. So you have to know a little bit about SMD components and their properties to order the right substitute. For example, this capacitor was out of stock, but I ordered this doubled up capacitor instead as a replacement. But I had to make sure the pads were on the same footprint, the height wasn't too much, so that it fits perfectly, and most importantly, the electrical properties had to be exact or similar. This is just one example. You might have to order multiple substitutes and you have to go through and compare the data sheets to ensure the replacement is suitable. Long story short, a friend of mine was luckily in the United States, so he carried these items and brought them to Dubai for me, saving me about $75 in shipping. I ordered parts worth 3 VESCs just to make sure that the effort was worthwhile, as I planned to build 3 of these VESCs. At this point, I had no idea even if one would work properly. The total for the parts was about $120 for 3 VESCs, so it was quite a risk. Now once I had the components, it was time to place them. Placing the SMD components is extremely hard for a beginner like me. Since the parts are really tiny, and even with a microscope, you need a really steady hand to place the components properly. Apart from that, since there were about hundreds of components, it is very easy to mix them up since most of them look the same, or even miss a component altogether. So when I do SMD soldering, I use a big printout of both sides of the VESCs and also keep a list of parts with me. And as I place each component, I cross off the item from both the lists. Now this is a full day task given you do it right the first time. After that, I soldered them using hot air soldering station, which isn't much difficult. I have a full tutorial on SMD soldering, so that should make things a little easy for you guys. Once the VESC was done, it was time to program it. However, upon connecting the 12-volt supply to the VESC, the DRV chip fried up. It was gone. So I went through the process of removing it, cleaning the board, ordering a new DRV, look for any shorts, and resolder it. Take 2. I reconnected the 12-volt power supply and more fireworks. The DRV was sparking and it was dead again. At this point, I had almost given up. So I did a third and final attempt, and at this point I was thinking what went wrong the first time. I changed a couple of things, but most importantly, I thought the shorting could be due to using the wrong flux. What a noob mistake. So I ordered some non-corrosive, non-shorting, no clean flux and used that this time. At this point, while connecting the 12-volt power supply, I had made up my mind that this was the last attempt. This project had already sucked up a lot of my money and, more importantly, my time. If this attempt failed, I would just shove the parts and VESCs in a bin and never look back again. So once more I switched on the power supply, expecting fireworks. A few seconds passed by and there were no fireworks. I had successfully made a VESC. However, this newborn VESC still had a lot to be done on it. We had to program it. And to program the STM chip on the VESC, I used a cheap STM programmer. After successfully programming, the VESC tool was downloaded and the VESC was connected via USB. After a couple of tries, the VESC showed up on the BLDC tool and finally the VESC was alive and well. Now this project was painful but equally rewarding. If I were to build 3 more VESCs, the total cost per VESC would be about $50, which is great since a VESC out there costs about $100 or $120. But if the project had failed, I would have wasted about $300 and gained nothing in return. So there's always a risk while learning. The important thing is how you learn from it and improve. I hope this project inspired you a little bit. I will soon be making another skateboard and connecting the VESC to the motors and testing them. So stay tuned if you're into that kind of stuff and some failures. Thanks for watching, guys, and please give me a thumbs up if you enjoyed the journey. Keep fungineering, stay safe, and I will see you next time.